Hi, my name is Bruce and this is a video about straightening a hole. So let me explain that. I bought an 8-inch Vertex rotary table cheap at an auction recently, and of course, buyer beware, when I got it home I found that it was in less than perfect condition. It had been dropped at some point, the casting broken and brazed back together, and the worm shaft was bent and stiff and rubbing. So this is the worm shaft, and I managed to straighten that okay. It's now about a half a thou total indicated run out anywhere, so that will do, I think, for my purposes. But it runs in this bushing, which is just a cast iron bushing. The bushing has to turn in the casting of the rotary table, and the bore that the shaft runs in is eccentric, so when you turn the bushing it moves the shaft back and forth and engages and disengages the worm with the gear. So turns out I straightened the shaft, but guess what? That's as far as it goes. Well, a straight shaft will not go through the hole. Turns out that this cast iron piece is bent, which is a real surprise. The hole is not straight. So my task is to straighten it. So here you can see the straightness of this cast iron bushing. This section, which is what runs in the housing of the rotary table, is pretty straight. So there's half a thou only there. But on this section, watch. That's 9 thou. So if I was doing a run out, that would be 18 thou of run out just in that length there. So this piece of the casting is actually bent up like that. And if I look at the run out in the bore, wow, that's, what is that, 25 thou total indicator. The casting is mounted on a mandrel in the straight part of the bore, so in theory if the hole was straight then there'd be little run out here, but there's 25 thou. I think the best strategy is to buy a new piece of cast iron and make up a new bushing. It's not that complicated really, it's just some eccentric turning and 1 mil slot and a long bore. It's not that hard, so that's probably what I'll do, but I don't have any cast iron that size, so in the meantime I'm going to try and straighten the hole. So this is a diagram of the situation. Here is the straight section of the bushing, and here is the bent section. The dotted lines show the hole, and of course the hole is bent along with this portion. My plan is to bore this section straight, so I will bore it like this. The drawing is wrong insofar as it's not so bent that I will come outside the casting like I've shown here, but the principle is I'll bore the hole like so. Then that will leave me with a hole of a flared shape, and either the shaft will run okay and not have too much slop in it because there's enough bearing area in this area, or it won't. And if it won't, the plan is to braze some material into here and then rebore it. So that's the thinking. Let's see. So the next trick is how to hold this while I bore this bore here, rebore this bore. I would love to hold it on this portion. It's eccentric, but that's okay, forge job will do that. But then how do I dial in this bore, the bore at this end, when it's in the chuck? I don't have anything that would reach all the way down there. Remember, this is the straight section of the bore. This is bent, I can't dial it in here. So my thinking is to mount it on a mandrel. This is just a parallel mandrel that I made to see if it would go through the hole, which it won't, just like the shaft. This is a closer fit than the shaft. The shaft is a bit worn. And my thinking is to Loctite the bushing onto the mandrel, chuck the mandrel, and in the forge jaw, and dial it in. I'm going to modify this mandrel so that there's a smaller section that'll go all the way through the hole, and then I can dial in the small diameter on the end. That's the thinking so far. I would love to have a better way to do it, but that's all I've thought of so far. Let's see. I should really add this filler material here before I do any boring, because brazing may distort the casting a bit, and then of course you'd want to bore, for an accurate bore you'd want to do it after. But I don't want to do that because the brazing may distort the casting, and if I can get away with just reboring the hole, then I'd like to. Remember that when I bore this hole, it's only going to take out, it's going to be an egg-shaped hole. So if looked at in this view, top and bottom, it won't be bored at all. It won't touch this side because this is the bent side, and it will have this side only. So I'll have an egg-shaped hole, and maybe there's enough stiffness in the shaft to run in that hole pinned against the newly bored side by its straightness to function. So that's my thought process. Let's see. Oh, and I did consider just trying to, it's bent, it got bent without breaking, so I did think about trying to straighten it, but just by cold bending. But I looked on the internet, and it doesn't seem very encouraging about bending cast iron. There's not many people on there saying that you can do it, so I don't think so. The other thing I tried to do, I thought about, was sleeving, but if you look here, there's really very little meat here. You might get 2 millimeters of sleeve in there, but it would be, you might even run into that groove. So I really don't think it's feasible to sleeve it. So I decided to try boring using the glued onto the mandrel approach. So the bushing is glued onto a mandrel with Loctite, and I will try boring from this end to the bent part. I don't like this setup much because of this enormous stick out here, and also a long stick out on the boring bar. It's probably going to be messy. But I've never tried a Loctite glued setup before, so I wanted to try that. I just used Loctite 609, which is a general purpose Loctite, moderate strength, and it takes like 6 hours to cure, reach 100% strength at room temperature, so I left it overnight. So give it a try, let's see. So that's what the first little pass looks like. Stops there and tapers off. It seems to work okay. The surface finish doesn't look great, but it's probably no worse than what's there. And there it's no longer cutting, which makes sense because the piece is bent, so it's going to cut heavier early and taper off to nothing later. I forgot to mention that the other disadvantage of this glued setup is that you can't test fit the shaft in the bore because the mandrel's in the way. Boring bar also, but that can be retracted of course. So now I've taken about 12 thou out of the most bent part, and that's about the amount of bend, so I don't want to go any more. So now I'm going to take this off and check it out. The Loctite is supposed to come loose with a bit of heat. First time I've tried it, so let's see. So I have to take my hat off to the Loctite people. That would not come off, stinking hot, and it would not come off, so I had to take it over to the vise and punch it out with a pin punch. It was very, very well adhered. No problem whatsoever for turning. So here's the surface finish inside the bore. It's pretty rough, but it's actually the same all the way through the bore, so what I've done is pretty much the same as what was there. So the fit is now not where it needs to be. The shaft still won't go in, but it almost will go. In fact, it's kind of a push fit. So it's better than it was. The mandrel will not go. It stops pretty good. The mandrel's a closer tolerance of about 1 thou clearance on the mandrel, whereas the shaft, worm shaft, is a bit worn. It's probably 2.5 thou clearance. So a little bit more to do, and I'm going to try the different setup for holding this time, just for experience, and to do the rest. So now here's the setup for the second way of boring. I've got the mandrel with a reduced diameter here. It's pushed. The full diameter is here at a very close fit in the straight section of the bore. The mandrel has a reduced diameter to pass through the bent section, and then I'm indicating on the mandrel. In other words, indicating on the bore. So that's set up, and that will do for me. It's within a needle, or yeah, about within a needle, so good to go. So now I've taken about 7/1000ths of an inch off the side that's rubbing, I guess, and the shaft now fits. So there's the shaft, the worm shaft, partially assembled. There's no thrust bearing or anything, but I just wanted to see if it's, you know, just how it works. And it actually works pretty well. There's no lubrication in there, and it's just nice and free. Cannot feel any play, but you know, everything's loosey-goosey without proper assembly. So far so good. I think that may be serviceable, if not beautiful. I also faced this surface here of the body, because if it's bent this way as it happens, then the face will be off square and the thrust bearing will sit only on a high point. So I just faced that on the axis of the piece, and hopefully the thrust bearing will work. It doesn't actually matter that this piece here, this section here, is bent, because nothing rides on it. This just is how you engage and disengage the worm, and everything else rides on the shaft, the hand wheel, and so on. The scale, the stationary scale, clamps to this, but that doesn't matter. That's slightly off, you know, bent. So I figure it should work. So there it is, completed. Looks like it works. It's smooth. It's not binding. I haven't measured the backlash, but I'll do that in due course. But it looks to me like that's going to be serviceable. In terms of backlash, the worm is engaged, and just manually pushing the table back and forth. I'm thinking that's around 6 or 7 tenths of a thousandth of an inch of backlash. I don't know what it's supposed to be, but that seems pretty reasonable to me. The operation is smooth. That can be adjusted, so if necessary I guess I can tighten that up. And just to note on backlash, there are 2 grub screws in here, and they adjust the limits of the rotation of the bushing and therefore the engagement of the worm. So when you disengage there's a limit, and when you re-engage there's a stop, and basically the bushing stops against one of these grub screws. And so to change the backlash, just adjust the grub screw and back in business. So there it is, one functional rotary table. It's pretty smooth, not 100%, but it's pretty smooth. So I think that will do. I should have mentioned the other way of repairing the bushing for the worm shaft would be to fill the sort of vacant part of the hole with Moglice or one of those kind of products. I have no experience with that. I don't know where to buy it. I haven't really thought of that, but I suppose that would be a valid way to build up the bore of the bushing without brazing and risking distortion. So the table drives nicely. Note that you should only drive in one direction because the thrust bearing is only in one direction. There are not 2 thrust. There's not a bidirectional thrust bearing in this thing. Then of course unlock, disengage the worm, and the table is free to turn to set up work. Re-engage and lock, and back to what the thing is designed for. So there it is, a straightened hole and a not perfect but serviceable rotary table. I hope you found something interesting in this video, and bye for now.